Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I'm your host, Dean Phillips, and the show today is brought to you by the Precision Metal Forming Association and the PMA's Educational Foundation. We appreciate them as a sponsor and appreciate all that they do for manufacturing. I'd like to introduce everybody to our guest today, Dr. Tom Kurfess from Georgia Tech. Tom has been also the SME president this year and has done an excellent job in that also. He's a professor at Georgia Tech and is the HUSCO Ramirez Distinguished Chair in Fluid Power and Motion Control. He's spoken before Congress and talking about some of the importance of manufacturing and why we need to stay focused in that area. Tom, welcome to the show.
Well, thank you very much, Dean. I do appreciate it, and it's great to be here.
Thank you so much. We appreciate you taking time out. You're already doing double, triple, quadruple duty with everything that you currently have going on, so I really appreciate you taking some time out to talk to our audience today, and I really do appreciate that. Tom, tell us a little bit about your background.
Sure. Well, first of all, it's really a pleasure to be here, and I don't mind at all the extra duty because, frankly speaking, we have a pretty good story to tell, and it's always enjoyable to tell such a good story. So, my background: I grew up in the Chicago area. I worked actually in our family machine shop back in the 70s and early 80s, and then I went to I applied took the SATs. They said they'll send them to 3 schools. Well, I was going to go to Purdue or University of Illinois, and then they said, well, we'll send your scores to a 3rd school. And I said, well, I don't know. How about MIT? And I wound up going to MIT, and I did all of my degrees there. I've got a bachelor's, master's, and Ph.D. in mechanical engineering from MIT, and then another master's in electrical engineering and computer science. From there, I went over to Carnegie MellonUniversity on the faculty there. But when I was there, I worked with a number of companies like Timken. In fact, I met my wife as an undergraduate intern over at Timken in Canton, Ohio, and we spent time over Carnegie Mellon, came to Georgia Tech, but also spent a fair amount of time at Lawrence Livermore National Labs out there in California, as well as Sandia National Labs. Then from Georgia Tech, I came to Georgia Tech in '94. Then in 2005, I went to Clemson to start up their International Center for Automotive Research as the BMW chair for manufacturing. So we're closely with BMW production operations in their Spartanburg plant. Mm-hmm. I came back here in 2012 to Georgia Tech, and on my way back, actually, I came back to Georgia Tech, but I came back via Washington. I was the Assistant Director for Advanced Manufacturing at the Office of Science and Technology Policy and the Office of the President of the United States of America, working for the Obama administration. Basically was responsible for engaging the entire federal sector and the greater scientific community to identify possible areas for policy actions related to manufacturing. I also coordinated all advanced manufacturing R&D and basically identified commercialization opportunities where the gaps in the current fields were for federal R&D and advanced manufacturing, and then developed the strategies to address those gaps. So sort of a mix of big companies, small companies, national labs, and even some government in there.
Excellent. Well, we do appreciate all the hard work you've put in for manufacturing, both in and out of government. We do appreciate your hard work.
Well, coolant's running in my blood. That's all I can say.
Yep. I mean, you come out of that firsthand, working in the shop like that. I'm sure that gave you a different perspective than probably a lot of people, certainly in Washington anyways.
Yes, it did. I mean, and I have to say, I mean, I know, we have all the, sort of the different sides and so forth with the politics, but what I can say about, our leadership in Washington, and really it just doesn't matter what party you're looking at, is they're all for manufacturing for very obvious reasons. It's great for the economy. It's so important to national security and so forth. And I can say both sides of the aisle were very supportive of our efforts in manufacturing, and they continue to be so today.
Excellent. That's always great to hear. Tom, tell me a little bit about what you see going on and how it will impact us in the destiny of manufacturing 5 years from now what is your vision?
Yeah, so I mean, I think and a lot of people are saying, so what's kind of the big innovation that's coming on in the whole bit, and frankly speaking, I don't think there's anything super new in terms of here's the latest and greatest technology, but there is a lot of, I think this is important for manufacturing. Look, there is a lot of, in manufacturing, it's all about, hey, I've got to be able to produce consistently, reliably, by keeping my operations up as much as possible. In a very efficient manner. And so really what we're seeing, is that there is a lot of technology, very tried and true technology that's out there that's now being brought together and integrated and really focused on manufacturing. So you look at the Internet of Things. Well, let's say, things have been around a long time and Internet's been around a long time. And really it's all about, how do we monitor, our machines? Even things like, we're looking at our CNC controllers. They have MT Connect on them. Well, it's been around for quite some time, but people are just now starting to figure out, I can look at this and understand, how well I'm doing and what my quality levels are, and I can do it from a global perspective. So really, it is a lot of great capability. Then you have, the latest and greatest in CAD and CAM. A lot of the gaming, area. You think, well, what do games have to do with it? Think about the great graphics that are out there, really driven by the gaming industry, and we're starting to really leverage that, in CAD and CAM and simulation and so forth. So really understand, I mean, NVIDIA, right? They make the big, graphics, U.S. company making these big graphics cards that everybody is buying. We work close to them in the manufacturing sector. So a lot of that is coming together to really give us some great capabilities. And of course, other things coming along, additive manufacturing, so 3D printing. That has been around since the 80s, but it's now really coming to fruition in terms of, both on the polymer side and the metal side, and then these new hybrid machines where we have both additive and subtractive. So we've got let's say a 5-axis milling machine, right? That's removing material. We just took delivery on one over at our facility, from Mazak, right? Where we're just pushing the limit in terms of what we can do with these things, and it is going to be amazing. So the next 5 years, it's hard even to predict what's going to happen in the next year, the next 5 years. But I mean, all this technology is coming together. That in conjunction with, the kids today, right, that are coming into our classes and so forth, they're just spun up on all this technology. They've got little home 3D printers and they see what's going on. They have the internet, so they can see exactly what's happening, what the trends are. And so they're coming to our offices, at Georgia Tech and saying, hey, we want to work on this. So they're already spun up on things. I think very different than, when I showed up at MIT. I was probably one of the only few, freshmen who actually knew what CNC was. All these kids know all about it. So it's a very exciting time.
Yeah. No, I couldn't agree more. It's very different. And the students today are definitely more tech savvy than certainly I was when I was in college. I certainly, it took me, and I came out of a vocational high school where I had worked with a lot of technology to start with at the early days, back in the rock and hammer days, probably going back that far. But there's no question that technology is driven by the students today. They can do so much more and are ready to do so much more, and I'm really excited about that. Let me ask you this: when it comes to where education is going today to prepare us, where do you think that that will shift in the future, or will it just expand upon itself?
Yeah, so it is very interesting where education is going today, and I think every generation of faculty, will say, well, the kids aren't like it was when we were students and the whole bit, and the reality is, that is the truth. I mean, the students today are thinking differently than we were, when I was a student 30, 40 years ago. And it's just a sign of time. I don't think it's a good thing or it's a bad thing. It just is what it is. Look, when we were students, right, Dean, we were working on lawnmowers, working on car engines and so forth. Crack open a new car engine today, you just can't get to it, right? But a lot of these students now, they've got Google out there, and so they're searching the internet for answers. They're doing 3D printing and so forth. So they have a different set of capabilities, but they're very tech savvy.
Yeah.
I'm just looking at a lot of the products that are out there. They're driven by, little chips like the particle photon, for example. In fact, you see all these little scooters going around. One of my students told me, inside those, little electric scooters everywhere, particle photon, right? And we use it all in, manufacturing and everything in terms of monitoring and so forth. Kids are coming in knowing how to program them, and these are like $20, and yet this thing has more power and more capability than, the main computer that put Neil Armstrong on the moon. So, maybe they can't tune an engine, although I'm not sure that anybody could tune one of those new engines without, thousands of dollars of computer equipment. But boy, oh boy, they really understand, some of the latest technologies, the Internet of Things, the 3D printing. And by the way, I find that there are 3D printing skills and so forth. And of course, in order to run that, they have got to have some CAD background and capability. They've got great 3D visualization. And so where I think it's going, personally, I think it's not about, how much more can we pack into our curriculum, but it's about the process. As new information is coming along, how do we roll that together and sort of, have the students, not just study it out of a book, because that's not how we teach anymore. It's not, here, read this chapter and we're going to lecture to you, but, engaging them through, a wide spectrum of tools. It certainly could be lecture, but there's a lot of, internet capability. There's a lot of social media and so forth, and a lot of interaction that the students do among each other and even among students from other universities. So it's really becoming more efficient and putting together a process, on the educational side that gets that new technology, that gets that new understanding and capability, into our curriculum. It's a constantly evolving process for us.
How have the tools changed for being a professor at Georgia Tech? How have the tools that you use changed?
Well, I think I was talking to one of my senior colleagues the other day, and we were sort of reminiscing the fact that instead of chalkboards, we have whiteboards. But it, of course, has gone much more, much further beyond that than just sort of changing from chalkboards to whiteboards and dry erase markers. In the classroom, the students are online. We could be sharing simulations. We could really, be going through, a lot of analyses and calculations and so forth. Where in the old days, I might have been up at the chalkboard and go through a lot, big, long analysis and calculation and so forth, which is not, in my opinion, yes, we still need to do this, but this is something where I can record this, let's say in a video or an MP3 or a podcast like we're doing now and say, hey, go through this thing, right? Because when I derive this, it's kind of a one-way street. When you're in class, let's go take a look at a simulation. So, we had this derivation, but let's show you what this really means, and why this works, And by the way, we've made some assumptions, right? Where are the limitations of those assumptions and so forth? And really give them some good demonstrations in class and allow them to interact and work with us. So that's part of it. The other part is when I was a student, we had oscilloscopes, and we plugged Polaroid cameras into oscilloscopes to get a trace of that scope.
Yeah.
I show this to my students. It's like they're looking, like you said, back to the Stone Age. It should be probably is in the Smithsonian. They love it, in terms of history. But, we went to digital, data acquisition, right? So digital, digitizing of the data on a computer. And now pretty much the students actually, as part of their, computer package, they buy their own A to D converters that plug into their USB ports. And so now the students are off taking their own data. So I don't need to, if I want to show them vibration, right, I don't need to, have something vibrating in the lab, with all sorts of sensors and the whole bit. I give them a little low-cost sensor. Your smartphone has a tri-axis accelerometer on it. It costs a couple of dollars. I give them a low-cost sensor that they plug into their A to D, board, that they have with their computer. And I send them out to the parking lot. I say, hey, just, stick this on. Don't scratch the paint. Stick this onto your car, and rev the engine to 3,000 RPM, right? And that 3,000 RPM, right, is going to give you, a 50 hertz, fundamental signal, right? And then depending on whether it's a 6-cylinder or a 4-cylinder, maybe you got an 8-cylinder, you can sort of go to a 3 or 4 harmonics and the whole bit. And they're doing it, right? So they're very hands-on. They're like, go out. And then not only do they try the car, but then they go to the lathe, they go to the bill, and they try everything, right? So they're much more hands-on, I think, than they have been, back in the day when we were just doing computer simulation. It is getting back, again, a different skill set, but it's getting back to when we were, undergraduates, and we really did have a lot of experience taking radios or TV. TVs are a little dangerous; they're high voltage, right? But taking them apart and so forth.
Yeah.
Again, different time, slightly different skill set, but at least they're getting more hands-on, which I'm very excited about.
Yeah. It's interesting that you say that because, and you talk about things going full circle. I really feel that there's a lot of that nowadays, especially in programming, kind of back to the early days of computers where everything was more open source. And now you see with programs like Python and things like that, you see more kids getting involved with doing these programs that weren't, you really didn't see them doing that 5 years ago. And it's really become a shift, and they're doing it just out of interest, that they're interested in it, not because someone says, hey, you got to go do this. And you see the same thing in the robotics competitions. You see it in a lot of the new areas that are expanding. As you mentioned, a lot of them have 3D printers in their houses now. Do you see that the students are better prepared in that way?
Yeah, so I mean, I think they're in some ways they're better prepared, and again, I think they're only 24 hours in a day, right? So if they're working on one area, then there might be something that they're lacking in. So yeah, I mean, I think that they're better prepared in certain ways, than we were, and in other ways, we might have been a little bit better prepared. So, for example, in many instances, they don't know what a crescent wrench is and so forth. Well, okay, because again, they're 3D printing things. In fact, they may have 3D printed a crescent wrench and they just didn't know it, right? But I mean, I think that's exactly right. And you look at it, and I mean, it's great because I remember when I was in high school, they're just coming out with the Commodore PET computer, and it was fairly expensive, and but it was great, right? And we had the whole high school had two of them, right, that you could use and so forth. Now, for $10 or $15, students are buying Arduinos, or you mentioned Python, right? So that would be a Raspberry Pi is programmed in Python. So for a very small investment, they can be doing this, and it's not just programming. There are connections to the outside world and so forth, right? So they can be driving things. And so really, I mean, as an educator, really what our task is, and this is why I say it's a continuously changing process. It's really about the process for us. Is to understand, what is the raw material that we have coming in, and what is their capability, and how do we tune our curriculum? How do we tune, our training experiences and our development experiences, to fit what they have in terms of their background? It doesn't make sense to, basically have them learn something that they've already learned, and on the other hand, we have to make sure that they have the right foundations and so forth. Because again, no educational, background is perfect. And so, in terms of coming in from high school at State University, in fact, actually, frankly speaking, the first year courses are the most difficult to teach because that's when you have to work towards leveling out the playing field. But I mean, it's a great time, and these kids that are coming in are just awesome. They are, I think it's an excellent time, to bring these guys on board. By the way, that's also not to say that, hey, it's just the current workforce. We're seeing this technology because it's so ubiquitous, smartphones and so forth. It's getting out into the current workforce. So I'm very excited about that. So I think it's not only is it a great opportunity for learning and development for our next generation, but I think it's the same thing for our current generation.
Sure. You mentioned a bit ago here about the Internet of Things and big data. We've been collecting data for quite a few years, and that was always the big push. We need to have more information. But I think when we got there, we realized we didn't know what we were looking at. And I think that what we see now is a shift in a different direction from just gathering data to actually having a purpose for it. What are you seeing out there in manufacturing in this change?
Yeah, well, and I think, look, this is not the first time that something like this has happened. And I remember, in the earlier days of Google and search engines and so forth, it would be frustrating. So, we have a lot of work in grinding. And so I tell my students, well, go, review the literature in grinding. And they would come back, well, I typed in grinding and I got 5 million hits. I don't know what to do. right? I mean, it's the same thing here. I've got all these sensors out here. We got all sorts of information. I don't know what to do, and we're figuring it out, right? And I think everyone out there that does their searches now do a smarter search than they ought to filter it out and so forth. And I think it's the same thing. We're getting pretty good at identifying, which data are important. And by the way, it's not always the data that you think are important, right? That are important. I mean, we're learning things like, oh, I didn't realize, these two things connected together, and so forth. That A causes B, right? Mm-hmm. But we're starting to figure that out. So, and then I think it is also getting better. So connectivity is getting better. Storage is getting cheaper. I think I bought I think it was a 5 terabyte hard drive for $120, and so forth. And I mean, I realized that, in the grand scheme of things, 5 terabytes might not be that much, but, my first hard drive, which was enormous, that cost, I don't remember how much money it cost, was 10 megabytes, right? Not gigabytes, but megabytes. and so, I mean, I think the technology is starting to catch up, with the amount of data, and our, what I would say our smarts, in terms of, being able to really process and utilize that data is starting to make a whole lot more sense and starting to also catch up with it. And that's, saying, look, we've got a lot of data at the sensors. We're not going to send everything up to the cloud. We'll process stuff locally. I mean, for example, if we're doing spindle analytics, there are a couple of key frequencies, what we might call the ball pass frequencies on the inner and outer, raceways and so forth. Those are the key things that you want to pass up. So instead of sending, 100,000 data points, we'll send 5 or 10, key data points after it's been processed. And you can think about that almost as data compression. Mm-hmm. And we do that, pretty well at this point in time. So, and by the way, it's not just that we're figuring it out, but this is also what we're teaching, right? And a lot of the students and a lot of the interest, I mean, this is becoming really ingrained in the culture is, this is how you do it.
Right. And I think that when you see that a lot of the information that we've been gathering for a long time, I think you said there cause and effect, and also basically combining it. Maybe it's this and this, or when you have this effect or this one, but not both. And I think you're right. I think we're getting smarter in our analytics and how we're going to process that information, and that's a big change. And but it's a great change. When you look at 5 years from now in manufacturing, what do you see as the biggest areas that we have opportunities to gain a lot of traction in?
Sure. I mean, I see a couple of major opportunities. Really, will be in planning. So as we get better simulation and so forth, we're going to say, okay, we can bring up a production line with fewer glitches in it, with more advanced capabilities. And as we bring that production line up, we can design it such that we can upgrade it, as new technology comes along. It's sort of a very easy fashion. So clearly, that's going to be a big thing. So, and that basically means less downtime. But I also see, I see some of the nasty jobs going away. I mean, these are just jobs that you just wouldn't have, and these are the not exciting jobs, and they're going to be automation is coming along and so forth. But I see some great opportunities for automation, for jobs in automation and moving things forward, robotics and so forth.
Sure.
I mean, some great examples, right? I mean, like the dishwasher. Everybody keeps asking me, when am I going to get the robot that loads and unloads the dishwasher? My answer is never. If you look at it, you've got to handle these fragile dishes. You put them in the dishwasher, and it's a really nice packing problem. When you're done, you take them off, put them away. That robot is never going to do it. But what we have done is we've gotten rid of that drudgery of washing the dishes and drying them, right? That's taken care of by a machine, and that's exactly where we're going to go. Other one, actually, if the listeners are out there, just go look up, the history of, ATMs, and tellers and ATMs and what happened to the teller job. ATMs come out, you'd think, that you'd have fewer teller jobs. Turns out there are more teller jobs, but those tellers are no longer counting money and doing your deposits. They're helping you, maybe open an account and working on different areas and so forth. So they're much more trained. They have much more going on, but it's great. I mean, they're higher paid in the whole bit. So I think that's one of them. A couple of the other ones that I see going on, and I could go on forever, right? But additive manufacturing, I don't see us 3D printing a car, I know people have done it and so forth, but I think additive is going to find its place, in the overall set of processes, and that'll come together, and that'll just fit into our operations, and so wherever additive fits in, it's going to do really well. But it's not going to get rid of machining and things like that, because really, frankly speaking, grinding a bearing, we're pretty good at that, right? And I just don't see us sprinting it. I think last thing is this whole smart manufacturing and Internet of Things for manufacturing. So, bottom line is there's just a lot of information out there that can really be used in a very simple fashion. And think about it. I mean, I'll just give you, the two examples, where we really just use information and how it's just changed our lives. Think about like Google Maps, right? Hey, I want to go somewhere. How do I get there? When I go on a trip, I don't even worry about maps anymore. I just say, this is where I want to go, and it tells me how to get from the airport to my hotel or to my meeting. The other one is the weather apps, right? I'm walking out of my office, let's say, to go to lecture. I bring the radar up right in front of me, and I know, I don't need an umbrella because that rain's not going to be here for a few hours, right? I mean, when I was growing up, when I was a kid, you had the 11 o'clock news, and you'd watch, you'd wait till 11:20 when the weather would come up, and that was it. They'd say, this is sort of our prediction, and good luck tomorrow. So I think a lot of that's going to be happening, in terms of smart manufacturing, and again, not just at the big, high-end, super advanced companies, but it's going to happen across the board. I mean, even now, people are buying CNC equipment. Even if it's in your garage, that piece of CNC equipment, a brand new piece of equipment, has all of the capabilities in there. And what we need, again, this gets back to your workforce development, is we need the workforce that can leverage that. And you leverage that, and the returns are going to be tremendous. So I think we're going to see, very modern workforce, and not just next generation, but current generation that's upgrading. I see, latest, capabilities in machines, and really being able to track and sort of understand everything that's going on and continuously improving, our operations.
Great. Well, Tom, I think we're just about out of time, and I really do appreciate you being here on the show today. This has been the Destiny of Manufacturing podcast, and Tom Kurfess has been our guest, Dr. Tom Kurfess from Georgia Tech. Thank you so much, sir.
Well, my pleasure, Dean, and thank you very much for inviting me on board.
Excellent. And we thank our sponsors, Precision Metal Forming Association and the PMA's Educational Foundation. We thank them for sponsoring our show. Go out and make it a great day.